Please like and subscribe to this channel and press the bell icon to get new video updates.
Well, good afternoon, everyone. So we'll talk about the mobile telephone. Our portable pocket-sized phones have become ubiquitous, but we're going to go back 75 years to when the mobile telephone actually started. And we'll talk some of the dates and some of the equipment, and Bill will talk about one of the early developers. So this picture is what happens when too many people get on a cell site at the same time. And that's actually what happened, although it was prefaced by the fact that there was workers on the tower apparently welding something on the tower, and they damaged some of the coaxes. But it wasn't realized until everybody, later in the day when people are coming home, when they're all on the radio. And the cellular system, you've got one or two antennas, the transmit antennas, that all the different channels use. And it was interesting. I worked with at Harris when we were setting up a developmental cellular system in Rochester, to watch the watt meter on the going to the antenna as you turned on multiple channels, transmitters, each one was 50 watts. So you see the watt meter go up to 50, 100, 150, 200, 250, 300, etc. So that's actually what happened, was that eventually the amount of power going through the damaged coax actually lit them off. Or, well, didn't, at least no flames, I guess, but a lot of smoke. Well, let's do some definitions first. Sometimes it gets a little confusing, especially radio telephone. Radio telephone doesn't necessarily have anything to do with telephone, with your landline telephone. It's just that it was when the first voice radios came available, it was like a telephone. So a radio telephone is really just any radio that transmits and receives voice. But a mobile telephone is a radio telephone that has a direct connection to the public telephone switch network, and is capable and licensed to operate in motion and at unspecified stops. So a car phone is then a mobile telephone installed in a vehicle, and a cellular telephone is a mobile telephone operating in a cellular mobile telephone network. So we're going to be mainly talking about some of the pre-cellular radios, but we'll get into the early days of cellular also. Before World War II, a few police departments had medium wave AM radios in their vehicles, but there was little or no manufacturing of VHF-M two-way mobile radios. During World War II, there were many advances made in the VHF radios, and after the war, VHF-M vehicular radios became practical for commercial services. 1946 is AT&T opened the first commercial mobile telephone service in St. Louis, Missouri, followed shortly thereafter by a system in Green Bay, Wisconsin. It was known as the Mobile Telephone System, or Service, aka MTS. By year's end, mobile telephone service was offered in more than 25 cities. It was a Bell System lease service, and typical rates were $15 a month plus 15 cents a minute. The service was mainly in cities and known as the urban system. The urban system used frequency modulation on 6 channels with 120 kilohertz spacing, but only 3 channels were initially used because of interference problems. The first mobiles were manufactured by Western Electric with 15 to 30 watts of RF power and push-to-talk. They were single channel radios. They received on 152 megahertz and transmitted on 158 megahertz. And they had built-in selective calling. In 1947, AT&T opened the mobile telephone highway service, initially between Boston and New York City. Highway mobiles received on 35 and transmitted on 44 megahertz. The service was designed for transportation companies. Initially, the country was divided up in 7 zones with only 1 channel per zone. And I kind of wondered about this when I first came across it. What are they doing for co-channel interference? But then I realized that they were worried more on E-skip interference. And with each zone on a different channel, even if there was E-skip, you wouldn't notice it because you're not monitoring the channel of, up here you're not monitoring a Texas channel or whatever. So here's a Western Electric Model 239. This is actually the Model 39A receiver and the 39 B transmitter, and together they were known as the 239. It receives on 35 megahertz and transmits on 44 megahertz. Transmitter has a dynamotor. It takes the 12 volts DC vehicle power and makes 400 volts DC for the transmitter. There's a pair of 2E24s, probably about 20 to 30 watts output. Again, this is a single channel radio. Here's the receiver. It has a vibrator supply, a single channel, and the big open area in the center there was for a plug-in selective calling unit. And then there's some big boxes in the center. Those are big multi-contact telephone type relays for the, again, probably used in the selective calling system. This is a similar Western Electric selector. The selective calling selector was a mechanical rotary stepping switch type of thing that had been used by the railroads and the telegraph companies from before 1900. Here's the control head, very simple, just a handset with a push-to-talk button. There's an on-off switch, a power light, and a call light. Motorola and Link made mobile telephones also. This is a Motorola installation, the receiver and transmitter, but there's a third box there, and that's the selective calling box. So they had taken their standard land mobile radios and made them into a radio telephone by adding the selective calling box. And you notice that nice tire in there too. All right, the first mobile telephones only had the manual service. Operators handled the calls in both directions. The mobiles were assigned a phone number, but a land-based caller would still first have to reach a mobile operator to make a call to the mobile. The operator would dial out the mobile's number using a frequency shift keying signal of 600 and 1500 hertz tones. Mechanical stepping relay in the mobile would compare the received digits that were dialed out. If a match was made, it would sound a buzzer and turn on a light to alert the driver. The mobile operated in half duplex, push to talk, release to listen mode. If the driver was not in the vehicle when the call came in, the light would be latched on to alert him to the fact that he'd missed a call. To place a call, the vehicle operator would remove the handset from his holder, press the push-to-talk button to turn on his transmitter, call the mobile operator, and verbally give the mobile operator the number to dial. The base station transmitters ran 100 to 200 watts. The mobiles generally ran 10 to 30 watts, although later 30 to 50. But the power levels are not balanced. The base could not always hear the mobiles. To solve this unbalance, the remote base stations were often installed around the city to provide better coverage. These were known as voting receivers, as a comparator would vote to see which receiver had the best signal, and that was what would be used. As the system grew, more channels became available. This required multi-channel radios with channel control selector. The mobile unit had to monitor a specific channel for incoming calls, but also had to manually find a clear channel to make a call. Some control heads had a revert function that would automatically put you back on your calling channel when you hung up. There were some manual systems that could remotely control the mobile's operating channel. It was sort of a semi-automatic system in that the channel selection was automatic, but the dialing was still manual. The mobile would monitor the calling channel. When a call was established, the base station would then move the mobile to a working channel to complete the call. When the call was finished, the radio would automatically revert to the calling channel. In 1948, AT&T could see that the mobile telephone service could become a major service if there were just more channels. AT&T petitioned the FCC for more frequencies for the service. Also, Bell Labs did a study and proposed a method of dividing up a mobile telephone coverage area into hexagonal cells, reusing frequencies in different cells. This system was very similar to what we ended up with in the 1980s. In 1948, Ramsey McDonald of the Richmond Telephone Company in Richmond, Indiana, built and installed the first fully automatic mobile telephone system, 16 years before AT&T had their automatic system. In 1949, the FCC allocated a few more channels to the mobile telephone service by splitting the existing 120 kilohertz channels into 60 kilohertz channels. The FCC gave half of these new channels to companies who were primarily not in the telephone interconnect business. The FCC referred to these companies as RCCs, radio common carriers, and this was the first competition to the Bell system. 1953, AT&T proposed to the FCC a broadband mobile telephone system operating in the 850 megahertz UHF television spectrum. In 1955, the FCC cut the mobile telephone channels width in half again to 30 kilohertz with deviation cut to 5 kilohertz. The FCC increased the number of channels in the 150 megahertz band to 18, with 11 channels assigned to the telephone operating companies, 7 assigned to the RCCs, but it was not fully implemented until 1963. 1956, FCC assigned 12 channels with 50 kilohertz spacings to the telephone companies' mobile telephone services on UHF frequencies of 454 and 459 megahertz. Later, the channels were split into 25 kilohertz spacings and half the channels given to the RCCs. In 1960, a mobile telephone system similar to the 1980s 850 megahertz cellular system was presented by Schulte and Cornell in Multi-Area Mobile Telephone System and the IRE Transactions of Vehicular Communications. Well, here's a typical mobile telephone radio transceiver of 1970. This is RF Communications Harris Series 400, also known as the RF 402 VHF transceiver. It's all solid state except for a quick heating 5894 tube in the final, could do 50 watts. It had been a marine radio, but they took the controls off the front and made it into a remote, trunk mount remote. The big hump on the front held the selective calling equipment. Here's a very simple early RF 470 mobile telephone control head. You can see down the side that there were lights and push buttons for the different channels, so you'd have to select a channel to make a call, and then it also had the optional revert switch to have you revert to your calling channel when you hung up. This is another manual service control head. This is a C-code head. C-code was a big manufacturer of signaling equipment, and they made all kinds of control heads, private labeled for RF, GE, Aerotron, Johnson, etc. This one is set up for it's like 10 channels or 11 channels for the RCC UHF band, but you can see there's no dial there, so you know it's a manual phone, manual service. In 1962, Bell engineers started working on a grand plan to duplicate their wired telephone network with a wireless one. But the frequencies and the technologies was not really available for what they wanted to do. So as a temporary solution, they announced a new automatic mobile telephone system called IMTS, the interim mobile telephone service. Interim until cellular came along. But calling a new system interim wasn't very good advertising, because you don't really want to tell people that this is just a temporary system and you should wait to buy the better one. So the name was soon changed to the improved mobile telephone system. It would be another 20 years before AT&T's dream of a high capacity, i.e. cellular, mobile service would become a reality. In 1964, IMTS finally became available in 25 cities. The rollout across the country of IMTS took a long time, and many cities never got the benefits of IMTS before cellular came in. MTS, which had stood for the mobile telephone service, now became the manual telephone service and continued to be available in many areas. In Washington, D.C., the telco VHF channels never got IMTS service, although there was IMTS service on some UHF telco channels. The U.S. executive branch had their own IMTS VHF system, complete with STU-3 secure telephone units on government frequencies around 172 megahertz. So the IMTS features, it provided direct dial to and from the mobiles, it eliminated the telephone company operator, it provided automatic channel selection, and it was designed for full duplex radio, so you could have a regular telephone conversation where you could interrupt each other, no longer push-to-talk operation. Although other systems were used, IMTS became the standard mobile telephone service in the U.S. for the next 20 years. The IMTS base station would generate a 2,000 hertz idle tone on one channel. That would mark the next channel to be used in either direction. All IMTS mobiles would search their local channels and lock onto the one with the 2,000 hertz idle tone. Your local channels would have to be programmed into your control head. If you drove to another city, you'd have to reprogram your channels again, although some units could store the additional sets of channels for use in other areas. When a call to a mobile was received, the idle tone would be dropped and replaced by an 1800 hertz seize tone. The mobile's number would be dialed out in audio FSK tones of 1800 and 2000 hertz. The mobile unit would then compare the received number to its own. If there was no match, it would drop that channel and scan for the 2000 hertz idle tone on another channel. If there was a match, the mobile would key this transmitter, send a 2150 hertz guard tone acknowledgement to the base station. The base station would respond with alternating idle and seize tones, which would initiate ringing of the mobile phone. When the mobile phone handset was picked up, the mobile transmitter would come on and transmit a 1633 hertz connect tone. The audio circuits of the base and mobile would then be activated and the call could proceed. The handshake and dialing between the base and the mobile was all done at mechanical dial pulse speeds, about 20 bits per second. When a mobile handset was returned to the cradle, alternating 2150 guard and 1336 hertz disconnect tones were sent. The mobile would then unkey and scan for the channel with the 2000 hertz idle tone. To place a call from a mobile, one would just pick up the handset. This would key the mobile transmitter and send a guard connect guard tone sequence. The base station would respond with a seize tone. The mobile would then transmit its ANI, automatic number identification, which was its 7-digit phone number, by toggling between guard and connect tones. If accepted by the base station, the mobile user would hear a dial tone and could start dialing. Dialing consisted of dial pulses of guard and collect FSK tones. Since the 2000 hertz idle tone had dropped, all the other mobiles would unlock from that channel and go look for the idle tone on another one. If all channels were busy, a mobile would continue to scan until it found a 2000 hertz idle tone. If a mobile came off hook when there was no channels available, a busy signal would be heard. IMTS problems. This was basically a trunking system and could easily be overloaded because the number of usable channels was severely limited. There were 4 different radio bands authorized for mobile telephone service for a total of 44 channels. Each radio band only had 7 to 14 channels for mobile telephone service. The radios had a range of 20 to 50 miles, so channels in one city could not be used by another city. Rochester could not use the same channels that Syracuse or Buffalo were using. The telcos operated the manual telephone service or the IMTS systems, but RCCs often operated with incompatible systems, such as C code 2805 or DTMF. For example, in the Rochester area, there were only about 10 mobile channels available total. 4 different companies sold service on 3 different radio bands. One radio could not access more than 6 channels. At rush hour, it was very difficult to find a free channel. In 1976, there were about 100,000 subscribers to mobile telephone services in the United States and 50,000 on waiting lists. The need for a high-capacity system was great, but would not come for another 8 to 10 years. Other automatic systems, C-Code had a system called SMART, C-Code Modular Automatic Radio Telephone, which was an automatic system that used 2805 hertz dialing and digital signaling. The C-Code systems were mainly used by the RCCs and some independent telcos. British Columbia Telephone Company, Autotel, used some of the best ideas of IMTS and cellular. It used high-power mobiles, 50-watt VHF, 30-watt UHF, with remote power control, full roaming, and large cells. The Autotel system operated from 1983 until about 2009, mainly in British Columbia. 1968, the FCC issued a notice of proposed rulemaking, docket 18262, to reallocate the upper UHF TV channels, 70 to 83, to private land mobile and high-capacity mobile telephone systems. Also in 1968, IMTS service became available on the UHF mobile telephone channels. 1970, the FCC released a study and requested industry to submit proposals for a new mobile telephone service in the 800 megahertz band. 1971, AT&T filed a proposal with the FCC for development and installation of a high-capacity mobile telephone system, which they called HC-MTS. This would become the standard for future cellular mobile telephone systems, but no other proposals were submitted to the FCC. But then we got this guy, you may recognize. This is Marty Cooper of Motorola, with his first portable cellular phone. Marty is often listed as or described as the father of the cell phone, but it's not the cell phone because AT&T had developed that long before, but he's the father of the personal portable phone. So he, in 1973, he placed a mobile phone call to Joe Engel, who was the head of cellular programs at AT&T, from that handheld phone on a street in New York City. And he told Joe Engel that the future of mobile telephones was not the car phone, but the personal phone. This was the first cellular call, but it was through a Motorola experimental system. In 1974, FCC allocated 40 megahertz in the 800 megahertz band for initial development of a commercial cellular mobile telephone system. The mobiles would transmit in the 835, 845 megahertz range and receive in the 870, 890 megahertz range, with 666 channels. In 1975, Illinois Bell filed with the FCC to build and test the first commercial HCMTS system in Chicago. 1976, AT&T started planning for the equipment test phase of the HCMTS system. They needed 850 megahertz, 666 channel, full duplex mobile radios for the test, but nobody was making anything like that at the time. And they only needed 100 radios. No one seemed interested in designing and building them, at least for that quantity of radios. Motorola had the technology and was doing their own tests, but for some reason they did not initially want to get involved. Finally, Oki Electronics of Japan agreed and produced the 100 radios and control heads for the equipment test phase. In March 1977, the FCC authorized construction and operation of the developmental system in Chicago. In July 78, the cellular equipment test phase commenced in Chicago with the 100 Oki mobile units. In December 1978, the service test phase started with over 2,000 mobile units now manufactured by Oki, Motorola, and E.F. Johnson. And the system is now referred to as the Advanced Mobile Telephone Service, or AMPS. AT&T thought they were going to own the system and lease all the equipment to the mobile users. This was just before the big breakup of AT&T. They did not want to get any of those original test radios to get out to prospective users and lose some revenue. Jim Troe, who was an AWA member, but now SK, was the manager of the equipment test. After the test was finished, he was told to destroy all 100 of the test radios. But Jim kept serial number 0001. And after about 30 years, donated it to the museum. And here it is. At the top is the actual control unit, which Oki made. On the side is a little curlicue linear antenna. Then there's the transceiver, the big box there, weighs about 30 pounds. And on the bottom was the logic box control unit that was designed and built by Bell System. If you look closely, you'll notice there's two coax connectors on that transceiver. One of the things that AT&T was worried about was that at 800 megahertz, there could be severe, in the cities with reflections from the buildings, there could be severe flood or picket fencing effect from reflections. So they wanted to run space diversity with these mobiles. The problem was that non-radio people don't like antennas on their cars for some reason, let alone two. And after the tests were done, they decided that picket fencing was not as severe as they were afraid might happen. And so they deleted the option for space diversity on the mobiles, but the base stations still use space diversity. If you remember the early original base station cellular towers, there'd be a big tower and then there'd be 3 separate collinear antennas at the top there. 2 were for receive and 1 was transmit. Today, they've gone into the sectorized panel antennas, and it's harder to see them, but I assume they're still running base diversity on the base stations. So what is cellular? I'm just going to cover the analog AMPS systems, which was in use from 1978 to about 2008. The main difference between cellular mobile telephones and systems and the previous systems was that in a cellular system, the coverage area is broken down into multiple small hexagonal cells, each with its own transmitter and receiver base station, aka cell site. This is a very flexible architecture as it lends itself to be easy to split cells or add cells or sectorize the cells. The cellular system radios used analog compandered FM audio. There was a supervisory analog tone of SAT of about 6 kilohertz to help identify co-channel mobiles, and it acted sort of like the tone-coded squelch. There was a signaling data rate of 10 kilobits, and the mobiles ran 3 watts of RF power or less because power level was controlled by the cell sites. In the pre-cellular systems, there was just one big cell for each city. That was the big coverage area. They could have a radius of 30 to 50 miles. And at most, you could have 12 channels, and typically fewer could be used at a time. The base station typically ran 250 watts, and the mobiles 20 to 50 watts. So here's the diagram of that. On the top is the typical conventional system where you had one base station connected to all the mobiles, and then the audio went through and controls went through to the telephone company. On the bottom is the cellular system where that area has been broken up into individual cells. Each cell has its own base station, and the audio signaling goes back to the mobile telephone switching office. And the MTSO is the brains of the system, and it's got to keep track of where all the mobiles are and which cells are in, so they know how to route any phone calls coming to those mobiles. In the cellular system, there were 333 channels available for each service. Remember, the channel selection was completely automatic. The mobile user had no control over the channel his phone was operating on. Each cell site had up to 3 paging and access, or P&A, or control channels. And each cell site could have up to 44 talk or voice channels. The cell site could not use channels used by the 6 adjacent cell sites. When a cellular mobile is first turned on, the mobile will search the P&A channels to find the strongest channel, which would be the local cell site. It then keys up and registers with that cell site. The cell site the mobile is logged into then sends the information to the mobile telephone switching office. The mobile in standby continues to check that it is monitoring the strongest cell site and re-registers with a stronger one if necessary. If it cannot find a P&A channel, it gives you the no service display. On a handheld mobile, it will go to sleep, but into a sleep mode to conserve its battery. It'll wake up about once a second to see if it's still on a strong P&A channel or to see if there's an incoming call. If not, it goes back to sleep. This is why your battery runs down faster if there is no cell service, because your the radio is staying on, trying to find the cell site. In the pre-cellular systems, if a mobile drove out of range of the base station, the call was lost and that was the end. But in the cellular systems, with the much smaller cells, a mobile could easily travel through the multiple cells during a typical phone conversation. So a method of continuing the phone calls throughout multiple cells was required. This was known as the handoff. When a cell site saw that one of his mobiles was getting weak, it would ask the adjacent cell sites to listen for that mobile. The cell site in the adjacent cell that received the strongest signal from that mobile would take over the mobile's call. It would switch the mobile to one of its channels and also switch the land-based telephone call from the MTSO to the new cell site. This switching is done in about 50 milliseconds, and the mobile user is not aware of the handoff. So in 1979, the first commercial phone service in the world began operation in Tokyo, Japan, because our FCC was still screwing around trying to decide what to do with the TV channels. One of the problems was that AT&T wanted to own the service, and Motorola was fighting to say, hey, this spectrum should be available to everyone. 1982, the FCC approved the first U.S. cellular systems with 2 licensees per market. One, a telephone company, aka a wireline, and the other a non-telephone company, aka a non-wireline. Each system had 333 total channels. In late 1983, Illinois Bell began the operation of the first U.S. commercial cellular system in Chicago with the Dynatac base station equipment. In early 1984, Harris RF Communication introduced the Alpha ET mobile telephone. It was a transitional unit and consisted of an IMTS transceiver, either VHF or UHF, and a cellular transceiver connected to a common control unit. Calls could be made and received from either system. It was designed for areas where cellular base stations had been installed in the center of the city, but there was no cell coverage in the suburbs or the rural areas yet. So here's that unit, the Alpha 40 control head on the top. There's a cellular mobile in the middle there, and then the Alpha 2000 VHF or UHF IMTS transceiver on the bottom. So the control head was like having a two-line phone, and you could program it to say what was the optimum service, such as you would typically program it for say cellular is my preferred service. So if you want to generate a call, place a call, you just pick up the handset and it would place the call on the cellular system. But if the cellular system wasn't there, you're out of range of the cellular system, it would automatically switch over to IMTS and make the call there. And you could receive calls on both systems. I was testing out this system for Harris in Chicago because that was the first cell sites available. And I actually had the condition of being on a call with someone and say, can you hold on a second? I've got a call on my other line as I'm driving through Chicago. Actually, I was sitting in the back seat and somebody else was driving. So it could actually do two calls at once. 1987, the U.S. reaches its 1 millionth cellular subscriber. Most mobile telephone or manual telephone and IMTS systems have shut down, although a few lasted into the present millennia. 1989, FCC added 83 channels per service to the 850 megahertz band for a total now of 832 amps channels. 1993, the first digital mobile telephone systems are established in the U.S. And the FCC reallocated 120 megahertz of spectrum between 1850 and 1990 megahertz for the personal communication services. 1995, the number of U.S. cellular subscribers reaches 25 million. 1996, the number of U.S. subscribers reaches 40 million. 20 years previous, in 1976, there had only been 100,000 mobile telephone subscribers. 20 years later, there's 40 million. In 2008, analog AMP service was shut down and replaced with the digital cellular.
Please like and subscribe to this channel and press the bell icon to get new video updates.